Differential Equations, Section 1, Tangent Fields. Video 3, Sketching Solution Curves. In the previous video, we viewed the solutions to dy by dx equals 2y on the tangent field. And we saw that the solution curve was like joining the dots together in the tangent field. We're going to have a look now at how we can use that to help us to sketch solution curves using the tangent field. So let's open up GeoGebra again. Here's the tangent field for the same differential equation, dy by dx equals 2y. Now, in an exam, we might be asked to find a particular solution through a particular point and then sketch it. And we might be asked to look at solutions through more than one point. So what I'm going to do is, I'm going to set up some different points, plot the solutions through each, and then have a look at how we can sketch them. So let's set up 4 points to start off with. A at the point 2, 2. B at the point 1 and negative 1. C at negative 1.5 and 0.5. And finally the point D at negative 1, negative 0.5. So I've picked 4 points, one in each quadrant, to try and show slightly different behaviours in each different region. Now I want to find the particular solutions through each of these points. So again, I'm going to use the solve ODE command that I used in the previous video. So first of all, solving f through a, and then secondly, solve ODE of f through b, solve ODE of f through c, and finally solve ODE of f through d. So I've got 4 particular solutions to my differential equation dy by dx equals 2y. Let's just make all 4 of these the same colour. There we are, that's better. Okay, and now I can start to see some of the differences and some of the similarities between the particular solutions. So in the same way that during the investigation of curves topic, we look for properties that were common to all and unique to some, I can do the same sort of thing here. So for example, I can see that all of them are starting to tend down towards the line y equals 0 as x tends to negative infinity, and I can see that they're all starting to get steeper as we go away from the axis. And if I look at the algebra window, I can see why. All of them are of the form y equals some constant times e to the 2x. So how am I going to get the solutions from here onto paper? Well, what I need to do is I need to have my graphing software open so that I can identify the key features and points, and then I need to pick particular points and look at what happens, look at how quickly it's going down from my particular point, like A for example, down to 0, and then I need to do that for each of the points on my grid for each of my 4 solution curves. So let's have a look then. Here's my sketch for those 4 graphs. So I started at a particular point, such as the point 2, 2. And then I knew from the tangent field what the gradient was at that point, and then I could find the gradient as it passed through each of those lines. And so I knew the gradient here. I knew the gradient here would have been 2. And then I can just smoothly join my curve together over each of those lines. And then I can show that it's tending down to the axis. I've got the same sort of thing here. I know that as it goes through these points, I know what the tangent is, and I know the tangent nearby. And then the same for my one underneath the axis here. And finally, for the 4th of my lines just here. So I'm using all the same techniques that I used for sketching curves from GeoGebra in the investigation of curves topic. I'm looking for similarities and differences between them all and using the tangent field to help me. In this video, you've learned how to sketch solution curves using tangent fields.